Hello, my name is Thomas Croft with Texas A&M University at College Station, and I will be presenting for the Animal Behavior Society the experiment me and my peers came up with, Do Bats Stop to Smell the Roses? A behavioral assay of the olfactory sensitivity in bats. Here's the overview of our experiment. We're just going to skip it because we're getting right into it. Here's the introduction. So we used Mexican free-tailed bats because they're easy and available for us, and these are insect-eating bats, and they usually find their prey by echolocation like many bats. Virtually nothing is known about how they use their noses though. So this experiment applied aversive conditioning to measure olfactory sensitivity in Mexican free-tailed bats. The bats were trained to discriminate between two choices based on scent. However, before we could do this, we needed to find something to either reward or punish them before we could attach a scent to anything. So to do this, we initially had glucose, and that didn't work out. So we used 2 water bowls, one containing quinine and one containing water. Quinine is a very bitter substance. For those of you who've had a quinine tonic, you may know that it is very bitter. So to record all these trials, video recordings were used. We would record the bats for 24 hours at a time, and then we would record them for 8 to 10 days in a row, and we would blind ourselves, meaning we would have one variable selected, and we wouldn't know which bowl had the variable in it until after we had counted both the sides, so that way we could avoid bias. So our first trial is experimenting with glucose. We used 20% glucose solution for the bats. Here's a photo of one of our recordings. The bats did not show any preference for drinking the glucose. We did this for about 8 days, and they would only drink collectively, the 10 bats that we had. They would only drink for about 4 times per night. So we found that they did not prefer sugar water. We don't even know if they can taste it. So this led us to try something else. We also had them in this big open room. So by confining them to a smaller cage, we could increase the amount of times they could drink water, which worked. So here we switched to quinine, and with the quinine they showed a clear bias towards wanting to drink just regular water, and they would visit the water much more. They went from visiting an average of 4 times a day in previous conditions to an average of 21 times per day, which is much better for us collecting good data. So now that we know that they don't like the quinine water, they don't like the bitter taste, we can attach a scent to it. Before I get into that, let me show you this video. Here, a bat's going to taste the quinine water. You can see that sharp recoil. It does not like it at all. So let's watch it one more time for good measure. It tries to drink it, and ooh, it does not like it. So we attached a mango scent. We chose a mango scent because it's pretty universal across mammals. We would reapply the scent every day, and then we left the bats alone without recording them. We just had the mango scent with the quinine for about a week, and then we started recording them, and we took away the quinine scent. So it was just one bowl with a mango scent attached with regular water, and another bowl that had no scent attached with a regular water as well. So here's the results of that 10-day experiment. Here's my table. We have the days listed. We have which side had the scent on it, randomly chosen. We have the visits to each side. So 29 means they visited the left side 20 times and the right side 9 times, which is what we would expect because the scent is on the right side and they've been trained to avoid the scent. So, and then here's just the percent more and a color to show if it was what we were expecting or not expecting. And as you can see, day 8 and 9, we had some results that we were not expecting, where we had unfavorable visits. So what explains these unfavorable visits? Well, we believe that the behavior exterminated, and if you look at these last days 5 to 10, you can see that the bats just went to the left side for these days, regardless of where the scent was. So we believe because the bats wouldn't avoid entirely the scented side, some of the bats would pick up on this and learn to exterminate the behavior of fearing the mango scent, and they would just all huddle together around the left side as their favorite spot. But initially it did work, as we can see on day 3 and 4. They did switch sides when the scent was switched. So our conclusion is that the bats were unmotivated by glucose. That didn't work out. The bats avoided the bitter flavor water, and then they were able to initially successfully associate the scent with the bitter flavor water. The bats likely gleaned information from watching other bats test the bulls. Conditioning exhibited extinction over a period of 4 days in our case, so approximately 3 to 5 if you try to repeat it. Aversive conditioning can be used to measure olfactory sensitivity in insect-eating bats, so we know that they likely can smell mango, and this can be repeated for other scents. We're hoping to try to do this experiment with moth pheromones to see if that would work. And thank you for listening to my presentation.